Okay, on to the last of the 5 standard types of reactions. We've done synthesis, we've done decomposition, we've done single displacement and double displacement. That leaves us with combustion, arguably the easiest of the 5. You'll see why in just a second. The word combustion means that we're going to be burning something in the presence of oxygen gas, and that's important because that means that one of your reactants has to be oxygen gas, O2. Okay, the other reactant is going to be an organic compound. Now there are a lot of different kinds of organic compounds. We're going to limit ourselves to compounds that contain carbon and hydrogen and sometimes oxygen. Okay, that's it. So those are my reactants. Some organic compound plus oxygen gas. Our products are always carbon dioxide and water. Always. How often? Always. Say it with me. How often are they? Always. Good. Okay, so it looks kind of like this. An organic compound plus O2 goes to CO2 and H2O, and then all you have to do is balance. It's easy, easy. And I'll even show you a couple of shortcuts for when you run into trouble. So here are some examples. We're going to write combustion reactions, chemical equations, for the combustion of the 3 compounds that I've got listed here. Benzene, which is an organic solvent. It's also found in cigarette smoke. Pretty nasty stuff. It's a carcinogen. Butane, found in your average lighter, C4H10, that's a gas. And ethanol, which is the alcohol that grown-ups drink when they go out to have a good time. So all of our reactions are going to look very similar, but because we have different organic compounds that we're starting with here, the balancing will be a little different. But they're all going to have the same general skeletal structure. Okay? So we'll start with benzene. Benzene is C6H6, and that is a liquid. We always have O2 gas as my other reactant. A lot of people will forget to put the O2 in. You've got to do that. Okay? We will always produce CO2, which is a gas, carbon dioxide is a gas at room temperature, and water, which is a liquid at room temperature. Okay? There's your skeletal equation. Now we just have to balance it. Okay? Now I'm going to show you a little shortcut. You don't have to use this shortcut, but if you don't, you will find yourself having to go back and double everything because you're going to run into a sticking point. Here's the shortcut. Look at the hydrogens in the organic compound. Now this only works when you just have carbon and hydrogen here. Okay? Look at the hydrogens. If the number of hydrogens in my organic compound is double an odd number, so half of 6 is 3. 3 is an odd number. 6 is double 3, right? It's double an odd number. If that's the case, then I can save myself a lot of trouble just by putting a 2 immediately in front of the organic compound, because I'm going to have to do that anyway. Even if I don't use the shortcut, I'm going to have to go back and double things. Okay? So because half of 6 is 3, 3 is odd, I double this, and that'll save me some trouble. And then the other shortcut is I balance in alphabetical order. Carbon first, then hydrogen, then oxygen. The order they appear here. So I have 2 times 6 is 12. I have 12 carbons, so I put a 12 there. There's my 12 carbons. I have 2 times 6 is 12 again. I put a 6 there. 6 times 2 is 12. Now the oxygens. 12 times 2 is 24 oxygens there. 6 there. That's 30 oxygens on this side. And there's 2 there, so I have to make this 15. Okay? So there's my balance. Simple. Let's do the next one. Butane. C4H10. And that's a gas. Always add O2, also a gas. Always produce CO2, also a gas. And H2O, which is a liquid. Now let's balance. Half of 10 is 5. 5 is odd. I'm just going to save myself a lot of trouble and put that 2 in front. Okay? If half of this number is even, then you leave it alone and you'll be fine. You don't put a 2, you'll be fine. Okay? So that gives me 8 carbons, 20 hydrogens. 8 times 2 is 16, plus 10 is 26. Half of 26 is 13. There's my balance. Okay, that little shortcut with looking at half of the number of hydrogens, it only works when there's just carbon and hydrogen in the compound. If you have oxygen in there, like we do with ethanol, C2H5OH, that extra oxygen is going to not make that work. So that's okay. We'll just do it the regular way. We'll still do it in alphabetical order. That's a liquid. We always add O2. We always produce CO2 and H2O. Okay, let's balance. I'm not going to put a 2 here unless I have to. So for now, I'm just going to say I've got 2 carbons there, so I'm going to put a 2 there. Be careful here. I have 5 H's, but then I have another one right there. So I have a total of 6 hydrogens on this side. I can put a 3 in front of that. That'll get me my 6 hydrogens. Now let's do the oxygens on this side. I have 2 times 2, that's 4, plus another 3 is 7. So I need to get 7 over here. Now, if there weren't an oxygen in here, we'd have a problem. But because I already have 1, and I don't want to mess with this formula at all because that'll change my carbons and hydrogens. So because I have 1 here already, I just need 6 more. And that means I can put a 3 there. Now I have 1 plus 3 times 2 is 6. So 1 plus 6 is 7. Now I have 7 on both sides. And so now it's balanced. That's all there is to it. Combustion is arguably, again, the easiest type because it always forms CO2 and H2O.